Okay, here's the first video review for the final exam, and I'll start with question A, the difference quotient. Difference quotient asks us to evaluate the function at x plus h, so wherever there's an x we put some parentheses, and inside those parentheses we put the x plus h, and then we expand the multiplications and simplify, and we subtract the function then from that function evaluated at x plus h. So x plus h, the quantity x plus h squared, is x squared plus 2xh plus h squared. And as a reminder of why that is, when you multiply the first terms, x times x, that's where the x squared comes from. When you multiply the last terms, h times h, that's where the h squared comes from. But when you multiply the x times h and the h times x, you're producing the same product twice. So x times h and h times x are the same thing. So that's what we have here, and so we have two of them, and that's why that product is x squared plus 2xh plus h squared. Now we distribute the negative 3 across those three terms. Negative 3 times x squared is negative 3x squared. Negative 3 times 2x is negative 2xh is negative 6xh. And negative 3 times h squared is negative 3h squared. Then we just drop the parentheses from this x plus h, since there's nothing to distribute. And we subtract the function. Well, when we subtract the function, this subtraction has to be distributed to every term in the function. So negative 3x squared is positive 3x squared. Negative x is here, negative x, and then negative 4 is positive 4. And then, so yes, I've distributed here and here. Then the negative 3x squared and the positive 3x squared cancel additively, and the positive x and the negative x cancel additively, and the negative 4 and the positive 4 cancel additively. That leaves you with negative 6xh minus 3h squared plus h. So there we have that in the numerator, and we can factor an h out of all three of the numerator's terms, and that will cancel then with the h in the denominator, leaving us with negative 6x minus 3h plus 1. When you get to calculus, you'll really see the meaning and the implications of the difference quotient. All right, now question B asks us to complete the square for the purposes of determining the vertex. I don't actually have the vertex identified here. I forgot to do that, but we'll see what that vertex is shortly. So, in order to complete the square, you have to factor whatever the coefficient in front of the squared term is out of the variable terms. So you factor a negative 2 out of negative 2x squared, and that gives you x squared. You factor a negative 2 out of 6, and that gives you a negative 3. So we factor a negative 2 out here. This is x squared minus 3x. And we leave a space here to put in the value that completes our square. Well, whatever that value is determined by this coefficient here. So we divide that coefficient, negative 3, by 2, and then we square that. Well, a negative times a negative is a positive, and 3 squared is 9, and 2 squared is 4. So that's what goes in here, inside the parentheses, and it is plus 9/4. Well, we usually don't have a negative coefficient here, but this time we do. So what we've actually added here is a negative 18/4. Negative 2 times 9/4 is negative 18/4. So we've contributed a negative 18/4 to this function. That means we have to add 18/4 outside the parentheses to compensate. Well, 18/4 is 9 halves, 2 is 4 halves, And when you add those together, you get 13 halves. Now, inside these parentheses, because this is a subtraction, we have a subtraction here, and this will be x minus whatever this value was right here. Well, it's 3 halves, so x minus 3 halves squared with the negative 2 still out front. So our vertex is 3 halves for an x value, or h, and 13 halves for the y value, which we usually refer to as k. So vertex is 3 halves. Remember, it's the opposite sign and the same sign. So it's h equals 3 halves, k equals 13 halves. Alright, the flight of a demi-cannon fired from an English ship in the Anglo-Spanish War of 1654 to 1660 had a flight modeled by the function h of x, capital H being the height, at a distance of x meters from the ship. So it's h of x is equal to negative x squared over 980 plus x over 2. So we want to find out what the maximum height of a ball fired from this cannon would be. Well, that will be the y value, or the function value, at the vertex. So we identify the a, which is negative 1 over 980, and we identify the b, which is 1/2. So you realize we're factoring negative 1 out of 980 out of this term and 1/2 out of this term. So those are the a and the b, and they go into the formula, the vertex formula. H is equal to negative b over 2a. Well, b is 1/2. B is 1/2, and there's a negative sign out front. The denominator is 2 times negative 1 over 980, which is negative 2 times 1 over 980. And so to simplify that, the negative and the negative make this a positive expression, and so we have the 1/2 divided by 2 over 980 is 1 over 490, and the reciprocal of 1 over 490 is 490 over 1. So, simplifying this, we have 490 divided by 2, which is 245. Then we substitute the 245 back into the function to determine the function value, the k, the maximum height, the y value of the vertex. So we put a 245 here over 980, and 245 squared divided by 980 is negative, well, it's negative 245 squared over 980. That's 245, negative 245 over 4. And then this is 1/2 times 245, or 245 over 2. 245 over 2 is 490 over 4. So negative 245 over 4 plus positive 490 over 4 is positive 245 over 4, which is 61.25. 61.25 meters high. Now, the next question, next part of this question is, could this cannon hit a ship that was 500 meters away? If not, what was its maximum range? Well, the maximum range is going to be 0, the second to 0 of this function. So the cannonball will be fired, and we would consider that x equals 0, 0 meters from the ship, and the cannonball would fly, it would reach its maximum, and it would descend, and the function value at each end would be 0, so we're looking for the 0 at the far end of the inverted parabola. So to do that, we set the function equal to 0, which is what I've done here, and I've factored out a negative x over 2. Factored out a negative x over 2, which leaves an x over 490 minus 1 inside the parentheses. I set each of these factors equal to 0, and then find that, well, naturally, the first distance, where the height is 0, which is the beginning point before the ball has been fired. And the The second is x over 490 minus 1, this factor set equal to 0. Add 1 to both sides and multiply both sides by 490. So the cannon's maximum range was 490 meters, so it could not quite hit a ship that was 500 meters away. It would fall 10 meters short. Okay, next, question D. We are asked to sketch the graph of this piecewise function. So for x less than or equal to 2, the function is a constant function of 1. Less than or equal to negative 2. So, did I say 2? I meant negative 2. So, less than or equal to negative 2, the function value is 1. It's a constant function. That's what we have depicted here. At negative 2, I have filled this point in to show that the function's value at negative 2 is 1 because it's an or equal to, so that means it's included. Then, beginning at negative 2 and continuing to 2, although not including negative 2 and 2, we sketch a graph of the function x squared minus 4. Well, that's just the standard parabola, x squared, shifted down 4 units. So here it is, x squared minus 4, shifted down 4 units. And so it meets the line at negative 2 and positive 2, but because these are strict inequalities, that's what it's called when it's not an or equal to, I have the dots, the points, not filled in to show that the function doesn't quite go all the way up to 2 and negative 2. And finally, the last function we use is 1/2 x, and that's for x greater than or equal to 2. Now, as I suggested for, I think it was the second exam, you might want to sketch out all 3 of these, and then you use your eraser to eliminate the parts where the function is not on the graph. So the x squared minus 4 does not go to the left of negative 2 or to the right of positive 2. 1/2 x does not go to the left of positive 2. But you would start here with a y-intercept of 0 and go up 1 over 2, up 1 over 2 to sketch that line that has a slope of 1/2 and is just a straight line. And once again, I fill in the point here because the function is defined at 2, and so function starts here. This particular function starts here at 2 with a function value of 1. 1 times 2 is 1.